Alright, good morning. I don't know how much time I have left to try to make this recording, but I figure so since I do honestly right there and got a long time before I get to work. I hope so you could hear me. I'll find out. I don't have time to try to find YouTube things, so I thought I'd just quickly spit out a couple of things which I am pretty confident about. One, refrigeration is the act of taking heat from a place which it is not desired to a place, taking that same heat to a place in which it doesn't matter. It's inconsequential. That's the idea behind it. What is heat? Heat is basically, for our purposes, heat is a room full of people. Anytime you have molecules moving, you're going to have heat. Molecules vibrating all the way down to absolute zero, and that's where all molecular motion stops. Anything above that is heat. The temperature is sort of an arbitrary scale that we just use to measure what we feel, our perspective of heat. And liquid and gas, not much different between the two, except that liquid has higher densities. It holds on to itself really well. What I mean by that is you can put liquid in a glass and it'll push in two directions. It'll push down and it'll push out to the sides. Now, if you put gas in a cup, essentially it just kind of sits in the same way to the bottom and to the sides. But if you close the cup and add more gas to it, it pushes top, sides, and bottom. So there's that. With the gas, if you increase the pressure, you increase the heat. This is important when trying to take refrigerant out of a system. If you don't have a bucket of ice, sometimes you'll overheat the recovery machine. But if you continue to compress a gas, you can actually turn it liquid, because you've squeezed it into such a small space. You squeeze that same amount that its density grows larger and larger, and you got a liquid. And that's kind of what we're doing. That's how we create the vehicle that moves heat from one place to another. You'll notice when you put a cold glass of water on a counter that there's going to be liquid on the outside of the glass. That happens because you have room temperature difference in comparison with the immediate surrounding of that cold glass. The glass is transferring the heat of the cold water, and all life, everything seeks a homeostasis. It seeks a balance. Nothing likes to be unbalanced in this physical world. So what that means to us is that the heat, which always travels from hot to cold, put a spoon on the fire, and it takes a second for you to feel the heat in your fingertips where you're holding the end of the spoon, because it's traveling from hot to cold. It does not travel the other way around. Hot air does not rise. Less dense air rises. When you have less dense air, that rises. When you're heating up air, you're expanding the air molecules. That's why hot air balloons work. It's not because you're making the hot air balloon hot. If that was the case, you'd burn the shell of the thing. So less dense air rises. Hot goes from hot to cold. And so when you're changing the state, which is what you're doing when you're compressing the gas and making it get hot and bothered, you're changing it from a gas to a liquid using pressure. That creates heat. So what we're trying to do is remove heat. But you got to think about something. How hot is it outside? If it's 99 degrees outside and you've created a vehicle that only reaches 95 degrees, you're not going to get rid of the heat. You got to get it hotter than the outside ambient temperature. So you need to condense that gas to where it has a temperature higher than 99 degrees. Roof systems can be as hot as 110. The black roof covering is definitely hotter. Either way, you need to get it up there somewhere around 125. 125 degrees is a pretty good target. It's not set in stone. You have to check manufacturer information. Always check manufacturer information when you're not familiar with that piece of equipment. Get familiar with it. One of the best things to do is to put the phone to call the manufacturer, put that on speakerphone, and then check your phone on the internet for any documentation that you can find. That way you're not wasting your time doing absolutely nothing while the manufacturer takes his sweet time in trying to get you tech support, which is very hard to find, and it takes a lot of patience to do that. Now, we have to compress that gas hot enough to get the heat to transfer to the outside air. Now, that's going from gas to liquid. As you can imagine, doing the opposite would give you the opposite effect. Going from a liquid to a gas gives you a cooling effect, and that is true. So that's what we're doing with the evaporator, which is on the inside, or the inside coil of whatever you're trying to remove the heat from. 4 main components. You have the compressor, you have the inside coil, you have the outside coil. Between the two of those coils, you have a metering device. That metering device is designed to change the pressures between the two coils. And remember, we need to change the pressure. Pressure is directly related to temperature, and it's also directly related to the state of change. That may or may not be 100% true, but what you're doing is you're trying to go ahead and take that liquid and take advantage of its cooling effect. I don't know how much more time I have, but I'm almost to my work spot. I need to go get breakfast. That's another thing. Try not to eat a whole lot when you're doing this job, because a lot of times you're driving. I hate driving. It's probably one of the worst parts about it. Maybe it's therapeutic. I think one of the worst things is dealing with store managers. Always be polite. Yes sir, no sir. Take their BS. They're making $100,000 and they're sweating you over $10,000 worth of product that they already have insured anyways. Usually they're just a bunch of... Let's not go there. Back to the 4 pieces of equipment. Compressor, inside coil, metering device, outside coil. That's it for now. I gotta go get a veggie sub, dude.